Today we're going to look at section excuse me, section 6.3, simple interest. So there's truth in the phrase, you need to have money to make money. In essence, if you have money to lend, you can lend it at a cost to a borrower and make money on that transaction. When money is borrowed, the person borrowing the money typically must pay the person or entity that lent the money more than the amount of money that was borrowed. This extra money is the interest that is to be paid. Interest is sometimes referred to as the cost to borrow, the cost of the loan, or the finance cost. This idea also applies when someone deposits money in a bank account or some other form of investment. That person is essentially lending the money to the bank or company. The money earned by the depositor is called interest. Interest is typically based on the amount borrowed or the principal, which is known as the principal. The pairing of a borrower and lender can take various forms. Borrower may be a consumer using a credit card, taking out a loan from a bank, the lender. Companies also borrow from lending banks. Someone who invests in the company stock is the lender in this case. Company is essentially the borrower. In this section, we'll examine basic building block of interest paid on loans and borrowed credit, and the returns on investments like bank accounts. Simple interest. Interest to be paid by a borrower is often expressed as an annual percentage rate, which is the percentage of the principal that is paid as interest for each year the money is borrowed. Sometimes the interest to be paid back is simple interest, which means that the interest is calculated on the amount borrowed only. The length of time until the loan must be paid off is the term of the loan. The date when the loan must be paid off is when the loan is due. The day that the loan is issued is the origination date. So let's look at some simple interest loans with integer year terms. So the simple interest, which we'll label I, to be paid on loan with an annual interest rate of R for a number of years, T, with principal P, is found using interest equals principal times rate times time, where the decimal form of the interest rate is used. The total repaid then is T equals P plus I, or more directly, T equals P plus P times R times T. This total is often referred to as the loan payoff amount, or more simply, just the payoff. Note that interest paid to a lender is almost uniformly rounded up to the next cent. So let's calculate the simple interest to be paid on a loan with the given principal, annual percentage rate, and number of years, then calculate the loan payoff or total to be repaid. So remember, our interest equals principal times rate times time. Rate is in decimal, time is in years. So the principal is 6,700. The interest rate is 11.99%, and the number of years is 3. So we have I equals 6,700 times 0.1199 times 3. So our interest paid is 6,700 times 0.1199 times 3. So our interest paid is $2,409.99, and our payoff amount would be our principal, 6,700, plus our interest paid, $2,409.99, which is $9,109.99. Look at another here. Principal is 25,800. Interest rate is 6.9% and number of years is 5. So our interest is simply 25,800 times our interest rate, 0.069, times our years, 5, and we get 25,800 times 0.069 times 5, which gives me 8,901. That's our interest. To add our total, we have 25,800 plus 8,901, and we get 10743. $34,701. Beth is the owner of a small retail store in downtown St. Louis. The windows in the storefront need replacing, so she needs to take out a loan, $9,500 loan to get the repairs done. The rate she secures is 9.25%, and the term of the loan is 1 year. How much interest will she pay, and how much total will she pay? Well, the interest is the principal, 9,500, times the rate in decimal form, 0.0925 times the time, which is just 1. So our interest is 9,500 times 0.0925 times 1, which is $878.75. And our total amount is $9,500 plus $878.75, which is total payout is $10,378.75. Now, simple interest loans can have other lengths or terms. When a loan is paid back after a term that is not an integer number of years, but instead a number of months, the term of the loan or time, T, is expressed as a fraction of the year. So a 2-month loan, so for a 2-month loan, the time in years is 2/12 or 1/6. For a 5-month loan, the time in years is 5/12. For an 18-month loan, the term in years is 18/12 or 1.5. Samuel needs to borrow $8,400 to pay for repairs to a small manufacturing facility. He manages to get a simple interest loan at 17.33% to be paid after 6 months. How much interest will Samuel pay, and what is Samuel's loan payoff? So again, our interest is equal to our principal, 8,400, times our rate in decimal form, 0.1733, times our time in years, which is 6/12, or, well, let's just put this for now. So I have 8,400 times 0.1733. 6/12 is 1/2, so times 1/2. And I get the interest paid is $727.80. The payoff amount would be $8,400 plus $7,027.86. So the total payout is $9,127.86. To determine the interest I on a loan with the term T expressed in days, with principal of P and interest rate in decimal form of R, we calculate I equals P plus R divided by 365 times T. Here, R over 365 represents the daily interest rate. Alternatively, the above formula is equivalent to I equals P times R times 1 divided by 365 times T, where the interest rate remains an annual rate, but the time is expressed as a fraction of the year. Uh, so this is supposed to be T. So Heather runs a silkscreen t-shirt shop and seeks a short-term loan to pay for new inventory. They secure a $3,700 simple interest loan for 60 days at an annual rate of 18.99. How much will borrowing the money cost Heather, and what is her loan payout? So the interest is equal to the principal, $3,700, times the rate, 0.1899, times the days, 60 over 365. So we simply take 3,700 times 0.1899 times 60 divided by 365, and we get $115.50. For the payout, we start with our 3,700. We add our $115.50. We get $3,815.50 is the total payout. Next, we talk about understanding and computing future value. Money can be invested for a specific amount of time and earn simple interest while invested. The terminology and calculations are the same as already been seen. However, instead of the total to be paid back, the investor is interested in the total value of the investment after the interest is added. This is called the future value. The future value, FV, of an investment that yields simple interest is FV equals P plus I, or it equals P plus P times R times T, where P is the principal amount invested at the start, R is the annual interest rate in decimal form, and T is the length of time the money is invested. The time T will be an integer if the term of the deposit is an integer number of years. It would be a number of months divided by 12 if the term is months, and will be actual divided by 365 if the deposit is for a number of days. In the following, determine how much interest was earned on the investment and the future value of the investment if the investment yields simple interest. So let's use our future value formula here, which is future value equal, well, let me write this over here. Future value equals P plus P times R times T. So our future value is equal to the principal, $4,500 plus $4,500 times 1.88% in decimal form, 0.0188 times 3. So we have 4,500 plus 4,500 times 0.0188 times 3. And the future value is $4,753.80. And then in this case, our interest yielded is the future value minus the principal, which is $4,753.80 minus 4,500, which gives me $253.80 as the interest earned. Here we have a principal of 2,000. We have 2,000 plus 2,000 times an interest rate of 2.03 in decimal form, 0.0203, and we're going for 10 years. So I have 2,000 plus 2,000 times 0.0203 times 10. And I get $2,406. And to find the interest, simply take 2,406 minus 2,000, and I get $406. All right, next one. We have principal. Looking at future value equals principal 120,000 plus 120,000 times our interest rate 3.1% in decimal form 0.031 times our time, which is 100 days over 365. So we're going to take this 120,000 plus 120,000 times 0.031 times 100 divided by 365. And I get $121,019.18. And if I subtract 120,000 from that, I get $1,019.18 is my interest. Next, we have a principal of $4,680. And my future value is $4,680 plus $4,680 times my interest rate in decimal form 0.0155 times 42 months over 12, 42 over 12. So again, 4,680 plus 4,680 times 0.0155 times 42 divided by 12. And I get $4,933.89. And I simply subtract 4,680 from that, and I get $253.89 is the interest earned. A certificate of deposit is a savings account that holds a single deposit, the principal for a fixed term at a fixed interest rate. Once the term of the CD is over, CD may be redeemed, cash in, or withdrawn, and the owner of the CD receives the original principal plus the interest earned. The deposit often cannot be withdrawn until the term is up. If it can be withdrawn early, there is often a penalty imposed to do so. So Mia deposits $4,900 in a CD bearing 3.95%. CD term is 7 years. When she redeems the CD, how much will Mia receive? So we're looking for the future value. And we have a principal of 4,900 plus 4,900 times the interest rate in decimal, 0.0395 times the number of years. So again, 4,900 plus 4,900 times 0.0395 times 7. And we get $6,254.95. That would be her final amount. Paying simple interest loans with partial payments. Every example above, there's only one payment for the loan and one withdrawal from the investment. However, for many loans, your house, your car, your in-ground swimming pool, the loan will be paid back in two or more payments. Such a payment is called a partial payment because they only pay off part of the loan. When a partial payment is made, some of the payment pays for the principal, but the rest of the payment pays for interest on the principal. When making the first partial payment, the interest is calculated on the principal for the time between the origination date of the loan and the date of the payment. If another partial payment is made, the interest is calculated based on the remaining principal and the time between the previous payment and the current partial payment. So we have a simple interest loan for $50,000 is taken out at 5.15% annual interest rate. A partial payment is made 120 days into the loan period. How much of the partial payment will be for interest? So in other words, what's the interest on this loan in 120 days? So interest equals principal times rate times time. So our principal is 50,000. Our rate is in decimal form, so 0.0515. And our time is in years, so we take 120 and divide it by 365. So I have 50,000 times 0.0515 times 120 divided by 365. And we get an interest payment rounded to 846.58. A simple interest loan for $8,500 is taken out at 9.9% annual interest rate. A partial payment is to be made after 75 days. How much of the partial payment will be for the interest? So again, our interest is our principal, 8,500 times our rate in decimal form, 0.099, times our time in years, which is 75 over 365. So we have 8,500 times 0.099 times 75 divided by 365. And we get $172.91. A simple interest loan for $1,400 is taken out at 12.5% annual interest rate. Partial payment of $700 is made 20 days into the loan. After that, after this payment, what will be the remaining balance of the loan? So we paid $700 in, but how much of that was the interest? So we need to find the interest for 20 days. That is the principal, 1,400, times the interest rate in decimal, 0.125, times the time in years, 20 over 365. So I have 1,400 times 0.125 times 20 divided by 365 gives me $9.59 interest. Let me double check that math. 1,400 times 0.125 times 20 divided by 365. Yep. So $9.59 of it went towards interest, which means we reduced the principal by 700 minus 959, which is $690.41. So our new amount is 1,400 minus $6,900.41. 1,400 minus 690.41. So our new balance is $709.59 after that payment. Simple interest loan for $23,000 is taken out at 7.25 annual percentage rate. Partial payment of $10,000 is made 40 days into the loan period. After this payment, what will be the remaining balance of the loan? So again, we're looking at interest equals the principal, 23,000, times the rate in decimal, 0.0725, times the time, 40 over 365. We do this calculation, 23,000 times 0.0725 times 40 divided by 365. So $182.74 was interest. So from our $10,000 payment, $182.74 was interest. $9,817.26 went towards the principal. So our new principal is 23,000 minus $9,817.26. 23,000 minus 9,817.26. And our new balance is $13,182.74. And finally, we'll determine the amount to be paid at the end of the loan. To do so, we apply the formula for the loan payoff to the remaining balance. However, the length of time for that remaining balance is the time between the partial payment and the day the loan is paid off. So how do we do this? First, we need to determine the remaining balance after the partial payment. We calculate the number of days between the partial payment and the date the loan is paid off. This will be the time in our payment formula. And then we calculate the amount to be paid at the end of the loan, or the payoff amount, using payoff equals P plus P times R over 365 times T, where P is the remaining balance, T is the time found in step 2. So Paulo takes out a 75-day loan for $3,500. Her interest rate is 11.2%. If she makes a partial payment of $1,250 after 30 days, what will her payoff be at the end of the loan? So first we need to see the new balance. So we need to find out the interest in 30 days. And that is principal, 3,500 times rate in decimal form, 0.112 times 30 days over 365. So we have 3,500 times 0.112 times 30 divided by 365. So the interest is $32.22. So of this $1,250 payment, 32 of it went towards interest. So that means $1,217.78 went to the principal. So my new principal is now 3,500 minus $1,217.78. minus 1217.78, which leaves me a balance of $2,282.22. That's my remaining balance. Now the number of days remaining is 70 minus 30, or 45 days. So now we need to determine how much interest on this new partial, this new principal we'll pay in $45 or 45 days. So again, our interest is 2282.22, the principal, times the rate, 0.112, times the time, 45 divided by 365. So we have 2282.22 times 0.112 times 45 divided by 365, which gives me $31.51. So we'll add that to the principal, 31.51, 3731132. And this would be her payoff, $2,313.73. Next, we'll look at repeated partial payments. Car loans and mortgages, which are loans for homes, are paid off through repeated partial payments, most often monthly payments. Since car loans are often 3 to 6 years and mortgages 15 to 30 years, calculating each individual monthly payment one at a time is time consuming and tedious. Even a 3-year loan would involve applying the above steps 36 times. Fortunately, there is a formula for determining the amount of each partial payment for monthly payments on a simple interest loan. There we go. Didn't want to go quite that big. So the number of monthly payments A for a loan with principal P, monthly simple interest rate R in decimal form, where T number of months is found using the formula A equals P times R times 1 plus R to the Tth power divided by 1 plus R to the Tth power minus 1. The monthly interest rate is the annual rate divided by 12. The number of months is the number of years times 12. So let's see if we can work this out here. Russell buys a new car by taking a loan out from the dealership. After all the discussions are over, he finances to $23,660. The annual interest rate that Russell will pay is 4.76%. He plans to pay this off over 5 years. How much will Russell's monthly payments be? So here is our principal. P equals 23,660. Now, our rate is 4.76%, but that's not monthly, that's annual. So we need to take 4.76, and I'm going to go ahead and put it in decimal form and divide it by 12 and see what we get here. 0.0476 divided by 12. Not pretty. So my monthly interest rate is 0.00, and I'm going to go 397. And there's 5 years, so our time is 5 times 12, 60 months. So now we have everything we need here. So the amount is the principal, 23,660 times the rate, 0.00397 times 1 plus that, which would be 1.00397 to the 60th power, that's t, all over 1 plus the rate, and I'll go ahead and do that math. 397 to the 60th power minus 1. So 1.00397 to the 60th power. Key this in, and your calculator is 1.00397. There should be a button with the caret symbol on it and 60 and enter. So I have 1.00397 to the 60th power. So I have 23,660 times 0.00397 times, and this here is, we'll go 1.2684. 1.2684, which means this is also 1.2684 minus 1. Okay, so now I'm going to go up here, and I still have my 23,660, and I have 0.00397 times 1.2684, and that gives me 0.005035548, and this is just 0.2684. 0.2684 dividing. So now I have 23,660 times 0.0187613,562. Do that multiplication, and his monthly payment is $443.89. And that is how that works. Now we're gonna compute present value for simple interest investments. When finding the future value of an investment, we know how much is deposited, but we have no idea how much that money will be worth in the future. If we set a goal for the future, it would be useful to know how much to deposit now so an account reaches the goal. The amount that needs to be deposited now to hit a goal in the future is called the present value. Present value, PV, of money deposited at an annual simple interest rate of R in decimal form for time t in years, with a specified future value of FV, is calculated with the formula PV equals FV over 1 plus R times T. Note that the present value in this calculation always rounded up. Otherwise, your future value may fall short. Let's rewrite that formula here. So we'll have it PV equals FV 1 plus RT. So compute the present value of the investment described. Interpret the result. So I have future value of 25,000, a time of 10 years, and an interest rate of 7.5. So my present value is the future value, 25,000, divided by 1 plus 0.075 times 10, which is 25,000 over 1 plus 0.75 is 25,000 over 1.75, which is $14,285 and round up 72. Even though it's 0.714, I round up to 72 cents. And what does this mean? So in this account, if I wanted to have $25,000 in 10 years, I need to deposit $14,285.72, which isn't too bad. 11,000 in a year in 10 years? Not too bad. Okay, I need a future value of 320,000, and I need it 35 years from now, and the simple interest rate is 6.5%. So my present value is equal to my future value, 320,000 over 1 plus 0.065 times 35. So we have 320,000, 1 plus 0.065 times 35 is me 2.275. So I have 320,000 over 3.275. 320,000 divided by 3.275. And I need to deposit $97,709. And again, it says 90.923. I still round up to 93 cents. So my roughly 100 grand will more than triple in 35 years at that rate. So again, to have 320,000 in 35 years, I need to deposit $97,709.93 today. And I have a future value of 90,000, a time of 270 months, and an annual simple interest rate of 3.75%. So does 270 months work out evenly? Yes, 22 and a half years. This is 22.5 years. Same process. Present value is 90,000 over 1 plus 0.0375 times 22.5. 0.0375 times 22.5, and I get 90,000 over 1 plus 0.84375. Add 1 to that, and I get 90,000 over 1.84375. 90,000 and by 1.84375 gives me $48,813.56. Again, rounding up. And last one, it looks like. Kintara will invest the money in a CD that yields 2.75 simple interest when invested for 5 years. So that after 5 years, the CD is worth, how much must Kintaro invest so that after 5 years, his CD is worth $12,000? So this is the future value, this is the interest rate, and this is the time. So how much does he need to put in now? The present value, 12,000, 1 plus 0.0275 times 5. 0.0275 point zero 0.0275 times 5 equals, I have 12,000 divided by 1 plus 0.1375. Not looking too good. 12,000 divided by 1.1375. And that is $10,549.46. Okay, so that finishes up section 6.3. We'll look at 6.4 next time.